So let's just try it, not finding a tangent line, but just find dy dx, given the relationship that, let's say that y squared plus 3xy uh, plus x squared is equal to 0. So you could again solve for y, but just like before, we'd have a plus or minus because there is no function that relates y to x. But we can still ask, since the points that satisfy this will give us a curve, so we can ask what is the slope of the curve? What is dy dx equal to? What's the equation or relationship for dy dx? So as before, we'll take the differential of both sides and solve for dy dx. So we take the differential of the left-hand side, y squared plus 3xy plus x squared. That's the left-hand side, and it's got to be equal to the differential of the right-hand side. Of course, the differential of 0 is 0. So following our rules, the derivative will distribute across addition. So first, this differential will distribute it here, and then it goes to here, and finally, we'll pass it on to here. So the next line, just following our differential rules, says that the left-hand side is the differential of y squared, and it's going to be, so plus the differential of 3xy plus the differential of x squared. So that's the left-hand side of the equation on above, and it's equal to the differential of 0, which is 0. Then we're not done. We don't have solely dy's and dx's. We've got a dx squared here, a d3xy, dy squared. So we follow our rules. So the differential of y squared, we did that in the last problem, so that's 2y dy. Now here we've got the product rule, right? So it would be good for us, well, first off, we've got the constant rule. So this 3 follows the constant rule, so it just slides right out. It is not affected by the differential operator. Maybe I'll just be careful and write it there, so we're using one rule at a time. So this is 3 times the differential of xy. And then the differential of x squared is still going to be 2x dx. That equals 0. And now the differential here, because it's a product rule, right? I've got x being multiplied by y. So let's make sure that we know our product rule. And it says, okay, if I've got the product of two things, two variables, it's the latter times the derivative of the first plus the first times the derivative of the latter. So just following that pattern down here, we get that that this is equal to, so 2y dy, that hasn't changed. We know we're done with this expression because the differential has moved all the way to the right and it's just been attached to dy. There's nothing to simplify there. So this is plus 3 times, so it is y times the differential of x plus x times the differential of y plus 2x dx, all equaling 0. So we know we're done distributing our differential operator. Why? Because everything we see is just a dy or a dx. There's no more complicated terms than that, just a dy or a dx. So now what we need to do is collect all our dx's and collect all our dy's. So here I've got a 2y dy. And here I'm going to have, well, this 3, I'm going to, just for the sake of brevity, remind us, right, this 3 is going to distribute across the multiplication. So we've got a 3x dy here. So I can group those together. So I'm going to have 2y plus 3x all times dy. Those are all my terms that have dy's in them. And then my dx's, I've got a 2x dx here, and then I'm going to have a 3y dx there. So grouping those together, I get plus 3y plus 2x all times dx, and is equal to 0. Now I want to solve for dy dx, so I'll bring this over, getting that 2y plus 3x dy is equal to negative 3y plus 2x dx. And I will divide both sides. So this side I want to get the dx over here because I want it under the dy. So I'm definitely going to divide by dx on both sides. Whoops. Don't want to cancel it out. I'm dividing. Oh my goodness. I think I'm drunk. Just kidding. So I'm dividing by dx, and I'm going to mix two steps. Now I don't want this coefficient over here, so I'll also divide by 2y plus 3x. And I'll do it on both sides so that the equation stays balanced. Whoops, not a 3y, 2y plus 3x. Right, so dividing both sides by that, and squeeze this in the bottom. Sorry, I've run out of room, but I get that dy divided by dx is equal to negative 3y plus 2x, all divided by 2y plus 3x. So that is the equation of the slope of our curve. Dy dx is equal to negative 3y plus 2x divided by 2y plus 3x. That is our equation of the, that will get, so we put our point xy in here. This will give us the slope of the curve related to this equation here, y squared plus 3xy plus x squared equals 0.